Okay, so I'm gonna do a update on the Rover project, The Stubborn Pursuit of a Path. And if we have time, I'll go into some digressions on systems engineering, which is basically just some research that I've been doing, but I don't really know that much about it. So it'll be a subject to discuss. How do I change my slides? There we go. Okay, so previously, just to give a little summary of where the project was last time, what I've been working with is a off-the-shelf chassis that I got from, I believe, Adafruit, because I didn't want to deal with mechanical stuff because I didn't know anything about that. And I have attached a Arduino Uno to it and then did some sort of custom electronics in the form of the motor controller, which is a H-bridge that that came with the electronics kit that I was kind of learning Arduino stuff with. And then I also added a radio transceiver to it that acts as my remote control. And then there's a battery and charging circuit that has proven to be pretty useful. Associated with the Rover is a ground station, and this is where I can actually do my control. It has the exact same transceiver, and then is just another Arduino Uno that then I interface with over the serial link from my laptop. So I don't have a great picture of what that interface looked like at the time, but this is a picture of my daughter who was able to use the interface. It's really just a simple like command line tool where you can type in a command such as forward and it goes forward, you type back, it goes back, and you can tell it to turn. One of the issues with it was that the communication is two-way. So I have telemetry that's being broadcast from the rover and received by the ground station. But the interface itself, to view that telemetry data, you basically had to like type a command that says TO, and then it would start to display that telemetry data. You have to interrupt it, and then you can do commands. So you couldn't like experience the telemetry data while you were actually doing something with the rover, which was a bit of a problem. And I've got a slide here about what a lot of what those challenges were. So first off, the biggest challenge is, I don't know if you could quite tell quite as well from the that first slide, but if you see the rover moving around, it's this great rat's nest of wires on top of it. As all these projects start out, those wires were all very unstable, being just plugged into a breadboard. Every time my dog would get near it, because she really hates the rover, the wires would definitely like pull out. And even some of the connections, I think, were not that great. There was a lot of difference even in like how much voltage was getting to the different motors based on, I think it turned out that this was a wiring problem. I thought it was just the nature of these motors being cheap. So it's very unstable. It stopped working a lot. And then, as I mentioned, the ground station itself was like the interface, there wasn't that much I could do with it. Like you can do some slick things over a serial interface, but the ability to iterate on that interface wasn't very great. And then it became more and more clear as we got more updates from other rover projects. Like there just wasn't as much opportunity for collaborating when you've got like a fully Arduino based platform, because you can't take someone else's software, run it in a Docker container and see how it's all going to integrate together. You can't connect it up to the internet except over like this interface link, the serial link, which was getting a little bit complicated. So I know that was going to be a thing to work on. And I even mentioned that, I think, in the last update about here's what next steps, and a new ground station was number one on the list. And then the other challenges since the last update were digressions into other like random subjects, rover adjacent, that I'm going to get into a little bit. And then, of course, summer. So project number one, the rewire. The idea here was to take that breadboard and make a more permanent solution that would be more reliable and get a little bit more experience soldering. I had done a little bit of soldering on the first version, just because that H-bridge chip was going to be was soldered to like a proto board, but then there was just so many wires going everywhere. It was pretty difficult to work with. So I was just looking for just some other. I don't want to go too like have a printed circuit board or anything that advanced, but just something that would be slightly more reliable than what I had going for it. I'm gonna hang up some pictures of that, but even after doing that, like I still struggled to figure out how to fit these parts properly onto this chassis that I bought. It has all these holes in it, but none of them line up with where you want them to be. And it's like, unless you're going to custom print a holder for all your boards and everything, it's always kind of a mess. So here's a picture of the current version right now. And so what I ended up doing was taking a Arduino Uno or Arduino form factor hat, which is basically just a proto board, but it plugs into the Uno itself. And so I could get my wiring much more precise with that kind of layout. It was cramped and it was tricky to get the soldering to work there, but it was just way cleaner and way less wires going everywhere. And then these, I don't know if you can see my mouse, but the connectors here on the board where I can plug in the motors and plug in the power and screw those very tight ended up being those work great. And they just barely fit on this. Everything just barely fits on this board, but I managed to get it there. And then, as I said, like, even though I had way more room because I had this stackable hat on top, I still didn't have room for my radio transceiver or the power. And so I ended up putting that on another proto board. And for the first couple of weeks, it was kind of just hanging out on the side with a zip tie. But I really wanted to like build a mount or something. And so I think this was not too far long after Anuraj's tutorial someone's tutorial on 3D modeling. So I took a stab at doing that. I've actually gone through a few different tools now. But the first version I had my friend print, and that was pretty inspiring that I could just like make a mount to attach this thing to. This is the best version that I have, and I have a few other versions that are on the Twitter thread about how it didn't work for silly reasons. But yeah, so this just has some components that are attached to the back you can't see, but they're fairly secure now. So that brings me to digression number 1 in the 3D printing. The goal of at least this very first rover was not to do too much on the mechanical side. So I actually had no plans to get into 3D printing at all. But that first experience of making the first board mount, I was like, this is kind of fun. I want to learn more about how this works. So I ended up getting a 3D printer and was able to iterate a little bit on that mount, and like a couple iterations. And I was like, oh, this is great. The thing prints super fast. And the biggest time sink was really playing with the modeling tools and trying to get a workflow that allows me to work on other stuff, or that allows me to make revisions. That was the really hard part. And so I've actually spent a fair amount of time printing other stuff. I kind of got interested in the idea of making like a tracked vehicle. And so I experimented with making a wheel from scratch and making some treads that snap together and so don't require any external pieces, even though everyone says you should never try to make a mechanical part with PLA. I just wanted to see if I could do it anyway and learn the joys of trying to make something with precision that could snap together. So it was fun. I haven't gone very far beyond just I got this wheel to work and I got these treads to match up, and I haven't printed anymore. And then
designed this threaded wheel, or did you download the model from somewhere?
I did it all from scratch.
Wow. Okay.
This is I did it all in Fusion 360 actually. And then, yeah, I was actually visiting my parents when I decided I want to make a wheel, and I got all the way through a good amount of the design, and I was like, oh, I need math to tell me how these things need to be spaced. And my dad's a math teacher, and I was like, Dad, remind me how trigonometry works. And so it got it worked out, but it ended up being like okay, I've got some math to give me the basic idea, but then I needed to kind of tweak it just like a half a millimeter here, half a millimeter there to get the precision to actually line up right. But it's actually pretty close for this version.
So is this Fusion 360 a paid software?
There's a Fusion 360 license for hobbyists that is free.
Okay.
And it's a pretty remarkable piece of software if you can wrap your brain around it, which I'm not quite there yet. But one of the most innovative things is it's got like a change log at the bottom. So you like, as you make changes to your models, every operation you do is recorded, sort of like a git commit history, except it's all relative. And so you can go back in time and make a change to the scale of one part. And as long as it doesn't invalidate like the relationships that you created later, it just like all applies forward. So like you can change the size, if you construct your models correctly, you can like change the size of the very first thing you built, and then everything afterwards applies like perfectly. You just with a click of a button. So it's pretty neat, but I'm still trying to learn how to use it. It's very complicated. Okay, so second digression goes into Arduino cameras. So I'm super excited about some of the Rovers that I saw that all have cameras on them. And if you're going to do some sort of remote control over the internet, being able to have some sort of camera seems really, really necessary. But the kind of principles of my project are that I'm not going to just like I wanted to do as much as I could with the lowest tech available. And so trying to get a camera working with an Arduino sounded like an interesting challenge. I've tried so far 2 different approaches, and this is totally like in prototype form, not trying to integrate into the Rover at all. But the first one seems super promising, like this little tiny camera. I'll just show the pictures. This little tiny camera here operates over just a 2-wire serial link. And so you send serial commands to take pictures, to just tell it to retrieve the data. I spent so much time with this little tiny camera trying to get it to work properly that it's sort of insane. I ended up like rewriting the driver to work around some bugs that I think are in the hardware, where I don't know how this is possible, but somehow the onboard firmware is like shifting a byte every like 300 requests or something. Like there's some overflow inside of the hardware that's making it mess up. So I was trying to write a driver that would work around this bug, and it was quite the rabbit hole. I did occasionally get full photos out of it, but it's just pretty limited in how reliable it's going to be. And here's one of the fun kind of in between ones where you get the beginning of one of the images and then it just starts to fall apart by the middle of it. And you just get corrupted JPEG data. So the second camera I worked with is much more sophisticated and seems very solidly built. It's an Ardu cam, and it actually does video and whatever else if you have the hardware to power it. But I haven't gotten too far with that yet, but it seems like a pretty reasonable thing. The only weird thing about it, and can I go back a slide? Yeah. One of the weird things about it is that rather than the 2-wire serial interface, which I like so much, it uses both SPI and I2C, which I'm very confused about why a hardware device would need to use both. It sort of seemed like here's the 2 competing standards for how you can integrate peripherals with an embedded system, and it decided to use both. One of them I think is for camera data, and one of them is for like control data.
The SPI is several orders of magnitude faster than I2C. So you can run it in like several megahertz, 10 megahertz, 20 megahertz, but I2Cs, I think I have not seen it go more than 1 megahertz.
Yeah, that could be a part of it, but I couldn't try to like, wouldn't you sort of guess that it would just, everything would operate over the faster one?
Yeah, but SPI is like 1-to-1 device, and you cannot attach multiple devices without any, let's say, multiplexer to the SPI. So I2C is a a multi-device, so you can have several devices on the same bus, but on SPI you can't. But the problem is I2C can't have as much speed as SPI.
Interesting.
I'm thinking that the video stream is supposed to go relatively uninterrupted. And that's why they don't want to mix it with control. They want you to be able to very reliably, every microsecond, get a packet. And I'm wondering if that's what's causing your noise problems, that you have a timing problem, getting the data, suddenly you're doing something else. When you come back, you're off by 2 bits. And I don't know how you're connected to the SPI, but I'm wondering if that's what's causing your problem. And maybe you do have an option to pause the transmission of the image.
Yeah, I've only played with the static images, and the way those seem to be pretty similar in both cameras, into where you make a request for a certain offset and it sends that back in certain blocks of image data. But I imagine the video specifically would probably be much more sophisticated.
If you read the images in blocks, so you shouldn't have any problem.
Wait, Rhett, did you say your byte shifting error was with the 2-wire serial camera or the second camera? Which
yeah,
one
the byte shifting error was with the 2-wire serial interface. I do think that the same potential holds for, like, maybe the timing gets off somewhere, but it's at a low level, like the serial interface layer. And I can't for the life of me figure out what I could be doing different, or what could even cause this, like, byte shifting scenario.
Reading less.
So what it would be is that, so there's a header. So you send a block, you send a request to get a block of data. That block of data has a header on it. So you can kind of recognize what you're getting back as, like, the data. And then it has, like, an integer value that tells you how many bytes you're about to get. And then there's all the image data. And then there's a footer that matches the same, like, header data, right? And so what I would see with this byte shifting is I would start to get one less byte of the header each request. Like, I would be doing all these requests, they'd all be going fine. And then eventually one would come and I'd be short 1 byte of the header. Now that header has like redundant data in it that I don't necessarily need. So I could, like, skip it, but then the header data would show up on the next request. Like, the byte showed up late, but it was, like, out of order. It was super weird.
So trying to resend it.
So yeah, even if you asked for the exact same block, it would always be off by 1 byte.
So the vendor hasn't provided any driver for this.
They have, well, so I think this is one. Yeah, this one came from Adafruit. They have software for it. That's what I was basing all my stuff on, and it doesn't quite work. I ended up doing a PR against their driver to say, well, this can work around this weird rare error, but the fact that, like, I'm the only one that's ever hit it makes me super suspicious.
Yeah, okay.
But I don't know. Maybe this is a really weird thing to try to do on an Arduino. But anyway, that's a work in progress. I still got some more experiments to do to try to nail this one down. The other tricky part is going to be whether I can actually integrate this into the Rover, not just my little prototype, because then I've got to try to figure out how to download this image data over my transceiver connection, which is not exactly high bandwidth. So I'm just gonna have to, like, drip it out like I'm on Mars. Okay, but so back to the main project here is my ground station version 2, which is moving past the Arduino and introducing a Raspberry Pi. The idea here was to make for a much more flexible platform for interacting with the Rover, both improving the interface, but also being more open for other collaborative purposes. The approach, as I said, a Raspberry Pi, it connects over Wi-Fi and a VPN to my laptop or to whatever else I want to interface with. And then I've wired in the same transceiver, which the only reason I attended this when I did was because I was like, oh, I can actually use the same Arduino transceiver. I found some Circuit Python code that runs this radio. And so I can just like communicate directly with the Rover over that. So basically just swapping out the Arduino based ground station, and the Rover will never know the difference. It did not work out that way, but in theory, it's theory, it was true. Also, I wanted to approach composing this ground station in more like replaceable components, and just thinking of it as Linux is my robot operating system, which I will display
can you
here.
go to the previous slide? What are the things on the right, the red and the green circuits? What are they?
Yeah, so this is just, I just have this ribbon cable to do this breakout to the breadboard. And then
Okay.
all these wires here are just for this one transceiver chip.
Okay. And then what is the red thing?
This thing right here.
Yeah.
That just takes the ribbon cable and puts it
Okay. It's a
onto
breakout
the,
board.
yeah, it's just a breakout board. Yeah.
Okay.
Which, yeah, I was kind of curious. Like, I don't know how many people do hardware level stuff with Raspberry Pis. Is this like normal, or do people just like put jumper cables on the pinouts?
Like this is the first time I'm seeing this, but this seems like it's good for prototyping.
Yeah.
Yeah, but like if I would be doing it, I would just have bought these, have soldered pins on the transceiver and then used those cables directly to connect them.
Yeah, I see what you mean.
Yeah, but I think this is a good way to prototype. Yeah, I didn't know such breakout boards existed for Raspberry Pi.
Yeah, well, I was looking at it. I was like, how the hell am I going to attach all these pins to this? Like, it's pretty dense. It's like, it's not near as convenient as like the Arduino Uno, of course. So how do people do this? I'm like, oh, you can buy these breakout things, but the breakout board is like a quarter of the cost of the Raspberry Pi itself. Like,
Okay.
It's pretty
It's sort of
convenient,
absurd.
it's pretty convenient, especially when you have big fingers. honestly.
yeah, it's like, I can't deal with these little pins.
Well, I'm gonna need to do it, but I have a hat, so I can't even connect directly to the pins.
Oh, right. I wonder if there are more like generic hat platforms too that could like,
I think there is like a pin header extension hat, but then like how would you attach other hats? So you,
are they not composable? Guess maybe not.
I don't know if that exists for Raspberry Pi in which you could stack. I've seen some boards stacked on top of Raspberry Pi, but I haven't looked deeper into it.
Many hats include a configuration EEPROM. So the Raspberry Pi reads it and knows what's connected to it. So if you stack them, I don't know what happens.
Interesting. I actually have another thought on hats that I put later in the conclusions, but one thing I found was that what was a little bit disappointing was realizing that because I've created a hat for the Rover to clean up the wiring, it means I can't swap out any of the component. Like I can't swap out the Arduino Uno with something else without like matching that exact form factor. So they're very like integrated together now. So if I want to rebuild the Rover, I'm basically just going to rebuild it all from scratch because nothing is salvageable from that perspective. Okay, so the architecture of the software on the ground station. I've got this quick diagram I put together. My approach was to try to keep each of these functions as separate as possible and use files or Unix domain sockets to communicate between them. So the most critical one here is this RFM69 is the transceiver. And so everything is kind of based around how to get to and from that. I put in the kind of hardware devices that are used to interface with the hardware on the Raspberry Pi. I think that's true of anything. And so then I have one Python script that is based on the code that came from, again, I think probably Adafruit for how to interact with CircuitPython and this transceiver. So I hacked that together and did some of the async, I forget what that's called in Python. It had been so long since I had done much Python programming that there's this whole async infrastructure that I had seen it on some of Mayer's code, and I was like, what is all this? Like, it looks totally unfamiliar. I was like, what has Python done? I have no idea. But it's pretty slick, and I've done code similar to that was actually much, much worse because it wasn't native to the language back then. So I learned how all that stuff worked, got it together, and so I've got one simple-ish, one page long Python script that does the radio interface, and so it exposes over a Unix domain socket, this var stubborn radio. Any client on the local host can connect to that Unix domain socket, and any incoming data to the radio gets sent over that Unix domain socket, and anything that you write to it gets sent right out over the radio. So as far as that CircuitPython interface or script is concerned, like, it doesn't care what bytes you're sending or for what purpose, it just dumps them straight to the radio. So that's like the only little bit of Python is this one little script. The second component, which is what writes or what interacts with this far stubborn radio, is what I was calling ComSock, which is just providing a socket interface for the COM layer of, I guess I didn't bring this up again before, but if you remember, I've had basically this flight software middle layer that I've been developing that runs on both the Rover and on the ground station. Is this like a chunk of C code that handles the communication protocol, it handles, like, it has an event loop, it handles just sort of all the glue for the mission code, what I've been calling it, of the actual actions that are going to take place. And so that was really nice when I had two Arduinos that were communicating, and they're both exact same architecture, and they both have the exact same timing. Even I didn't actually realize that was going to matter. And they were just mirror implementations of each other. So moving to this new version of the ground station, now I've got still the same Rover software running, but now I need a little C program running on the Raspberry Pi that's going to at least provide the communication infrastructure. It's going to be able to read the packet format that's coming over the radio, and then output that to something that some higher level program is going to be able to consume. So it does that, and it writes. Sorry, what's that?
Why can't you do it in Python?
Oh, 100% could be done in Python, but I had already written it in C because it was running on the Arduino. So I was like, oh, this shouldn't be too hard. I should just be able to compile this to run on the Raspberry Pi. I don't want to do too much in C because it's kind of a pain. So I'm just going to have this very simple component that all it does is provide the command infrastructure, I guess you could say, where it's going to take the commands in, it's going to encode them as they need to be and send them to the radio, and then handle the data that comes back. And it does do that, but it was harder than I expected for some reasons I'll discuss. But so what's going to happen here is it's got this ComSock Unix domain socket that can get written to for commands, and stuff comes back. And then it also has this telemetry log file, essentially. And there's also a JSON version of it that it's just all the telemetry, the data comes back, it just writes it out to a log file. So anything that wants to consume that can in a text basis. And then the new component is this ground data system, GDS, and I actually wrote all that in Go. And all that is a interface, essentially. And so it can deal with these fairly simple interfaces to do the low level stuff, and then it can make it a little bit prettier and a little bit easier to use than the previous serial interface was.
I didn't understand what that GDS is.
So I'm going to show you. Demo time. If I can pull it up. Okay, so on my laptop, I can SSH into my Raspberry Pi ground station. And then I've got my services running are called radio. And you can see in the logs that it tells me just the data that's being read and write. And so right now this is all telemetry data that's been coming through the radio service. And then I have the ComSoc interface, and it logs out all the events that it sees. And so this event 11 is like, I received a message, and it's all telemetry data. And so if I go into my var stubborn directory, I've got telemetry data coming out of here. And then the Unix domain sockets are running there for programs to interact with. And then if I go to my interface, I have this. And so I've got this telemetry display up here in the corner, and then whatever log data I want in the main screen. I actually don't have much to show here, but I for a while I had some logs streaming there, but it ends up being kind of distracting because telemetry is updated every second. So it's just kind of like a constant stream of data that doesn't change very often, and it's duplicated up here. So this is like the most recent data that's come across, and it updates every second. This uptime is the uptime of the Rover. It's been running for 1 hour, 17 minutes. And I have it back here on the shelf behind me on its maintenance stand. So it's a little tricky to show it driving around. So I'm just going to leave it there. But basic communication, I have a no op command. And so it just logs what it was, the command that was going to run, and whether it got a response back. One of the focuses for earlier parts of the project was to kind of make sure that I had good observability and error handling and stuff. So there's an error, there's like a global error flag on the rover if something bad happened, but I can trigger it via this interface. And so you can see in the telemetry data, we're showing up on an error here, and then I can clear that out. And then of course I can actually just run this thing. It doesn't fall off because it's hitting something. And then I've got values for my motor showing up. And then it stops. So I've changed, since the last time, I've also changed the command structure a little bit to make it a little more fun to work with. And what I was finding was, so previously you would basically say like forward 255, that would be like maximum full speed ahead. And then you would have to like issue a command to stop, which means you have to be pretty fast to like not run into stuff. So taking more of the cues from what I saw with like Myers is like telling it to go forward for a certain amount of time. So it goes, it's got one static speed. Oh, actually I got 2 speeds. I forgot about that. I wonder if that still works. Yeah, it does work. So it goes straight to 250. Okay. Yeah, so you tell the direction and then how long you want to do it for, and that proved to be much more useful, especially for things like turning. So I've got like right turn goes like, oh, may not be working. The right turn will go like about 90 degrees, I think, and so you can do increments of 90 degrees. I think is how I had it set up.
Well, what is the possibilities that I could type the commands from here, and your camera on your laptop would be looking at stubborn, so I could see how it's reacting. Is
I
that
think it's
set up?
super close to be able to do that.
Okay. And,
Super close.
one of the reasons why I'm asking, Victor isn't here today, but on Sunday, Victor did a lot of work at home, but it was very easy after he did all that work to install OpenVPN on my Rover, and our Rovers talk to each other. They didn't have anything interesting to say except hello, hello. But no. We transfer data as well, for processing and so on. So that's why I'm asking.
Yeah, I definitely hoped that the way this is structured, so like whether it was anything is using this interface at all, like sort of doesn't matter, because you can trivially, actually, I'll do that.
Let's talk about the trivially, because we're trying to figure out what protocol to use for communication between the Rovers. And right now we're thinking about using HTTP-based interface of a very particular type, which is that you can send commands, which are actually Python programs on the client, or I should say on the target. So you can send it a command, and then it carries out that command. So I would send you by HTTP something like move command RT. And what your Rover would do, it would get the move command and say, oh, that's a Python move command in this directory. And I'll pass to it the RT. And then you will connect that to the interface you just showed us. So that is the direction that we're thinking of, because it looks like that is the easiest way to get the functionality we want. And
yeah, I think the only difference from how I was thinking was that I don't necessarily need to execute a script for forward, although I guess I could literally have like a bash script for forward. But
no, just a second. We don't care how you implement it. In other words, you have a script which gets a word command, and then it plugs it into that interface. We don't care if you have a separate script, how it's actually implemented.
The interface you care about is the web server or whatever is receiving.
So what we're saying is there's a web server, it gives commands. We believe that these commands should be executed as Python scripts. But when I say executed, it might mean that you're actually doing it in the script, or the script might just be a wrapping for something else. And so I'm just telling you that as soon as you're ready to connect up to the VPN, okay, it's Raspberry Pi. That's it. There's no other requirements.
I think we could do this.
Okay.
Yeah, I think that'd be pretty easy.
Is it like a one-way communication of the commands alone, or are we also talking about like outputs and stuff like that, like camera outputs and?
Okay, that's a good question. Victor says that we want to send commands, information, and data. Okay, so command is like move right, move left, take a picture. Information is like sensor number 2 says 55, and data is like a picture. So the idea is like an HTTP, I send a command to Rhett, and Rhett might send back a snapshot. Okay, it's HTTP, you can send whatever you want, but the details are not sorted out. We just know we want to do these things. And by the way, just sending instructions is not super interesting. One of the things we're talking about is how do I send data to be processed? Okay, so Rhett has an image, but he doesn't have a neural network-based object detector, but maybe Victor does have it. So we send the picture to Victor with a command of identifies the objects. and then he gets back a file with the objects identified. Okay, so that is what we want to get to. Because if we have a rover that's 1,000 miles away from another one, there is one interesting use case, which is when one rover has an algorithm for doing something and it controls the other rover. So let's say my rover doesn't know how to walk around objects, or even simpler, how to go through a doorway. But Rhett has an algorithm which knows to identify the doorway and tells the rover move right, left until it's aligned and then go forward. So I would tell Rhett, send me commands to move me through the doorway. Okay, now that's more sophisticated. We're not there yet, especially since Rhett is using wheels and I'm using legs. But at this level of abstraction we're talking about, that's not a problem. What is a problem that when I say right and when he says right, it doesn't mean the same thing. Okay, but that's what we're planning on doing.
So the commands are at a very abstract level. We are talking about them at very much abstract level, right? Or something.
Yeah. But we're not even sure if the abstraction levels that we have and the abstraction levels that, when I say we, the legs and the abstraction level of wheels are the same. But even when you talk about wheels, is Rhett able to turn in place, or can he only turn by moving forward? Okay, that's not the same type of right turn. So if he has a track, he can turn in place. But if he has differential control of the wheels, he can't. But if he has separate motors, he can. But if he has a little tail wheel, maybe he can't. So we don't know the answer to any of this. Okay.
Okay.
But I'm just saying that what we want to do is we want to have the rovers talking to each other, and we want them to share at the very beginning, just being able to tell each other what to do. But more interesting is having sharing processing capabilities, and even more interesting is remote control for particular tasks. Once we manage to do that, we'll want to do one step forward, which is, and I'm only interrupting here because Rhett is showing us that he's, the architectures are similar. We want rovers to be able to learn from each other. Sorry.
Cool.
One question to Mayor. Why does it have to be a Raspberry Pi?
It doesn't have to be a Raspberry Pi. And that's why what was interesting and what that showed, from my perspective, is not that it's Raspberry Pi, but that he's using Linux. Okay,
Yeah, so,
now probably doesn't need to be Linux either. Okay.
okay.
It's just that when you look at the stack we're using, and I said Victor worked quite a bit to make it happen, because it turns out that he wanted to do more, but I have a 32-bit operating system and he has a 64-bit operating system. And he said that ROS 2 doesn't really like that. So there are compatibility issues. Right now, we're talking about web server and Python and Linux for running the OpenVPN, for easily installation. And what that's showing is great support for that. And
So
yes,
the interface is, but not depending on the underlying hardware and OS, right?
Right, but I'm looking at Rhett's presentation of how the system works. Okay.
Okay.
He has a rover. The rover is connected to a base station. It doesn't even know what kind of base station it's connected to. The base station also doesn't know anything about the rover. The only thing that they know is I can give you a command and get back feedback. Okay, so that's a very interesting level of abstraction. And if you put it over HTTP, so I don't need to know anything at all.
I think it's interesting that there's kind of different layers of being able to share and collaborate. Like the most important one is that interface. So if we can agree on an HTTP robots over web services, like great, this is going to be easy no matter what. You can do that anything. But it's also convenient, at least, to be able to share code and share components. So if everyone had 64-bit Raspberry Pis, for example, you'd be able to share more stuff more easily, but it's not like a deal killer. Like I'm not going to be able to share any code that requires, I don't know, like using the hardware to trigger the motors to do something, like, or if that were a thing that we could do like that, because my hardware layer is completely separate and doesn't match anybody else. That's always going to be my custom one-off stuff, and that's fine.
What you see, exactly what we want to do is find a way to abstract out what you described into the interface. Okay, so the actual code you wrote, we can't share, but the higher level, which knows how to deal with it, we would be able to share. We hope. If we actually manage to separate the layers. Like I said, I have legs, you have wheels, and Venkatesh has boogies. These are very different things.
I want to make a connection to the thread Eric has been pulling at for the last few weeks, which is abductive reasoning. And also last week when Anuraj was talking about his affordances based architecture. I don't know if you've seen the video, Omer, but I think you've got this HTTP based API and you want this kind of abstract command that says, go forward, and whether it's wheels or legs, it appropriately translates. And that sounds to me like what we really want is a declarative language that does some abductive reasoning behind the API command, right? So when you say go forward 10 seconds, it tries to figure out the best fit theory for what that means in the local context and generates the detailed commands. And that's the abductive reasoning part. And the declarative programming, I'm thinking of this like last time I mentioned CSS is the only precedent I can think of. Like you send CSS and the browser, depending on whether it's mobile or laptop or whatever, it renders the CSS differently, right? So same kind of thing. This is like CSS for robot affordances that is computed through abductive reasoning. So I just wanted to mention that since I think that's an interesting thread, we should continue to trace through these talks. So Eric, did I sort of misrepresent your line of thinking, or is that roughly right?
The question is to me or to Rhett?
To you. I was just trying to like capture your line of thinking.
Oh yeah, so thank you, because yes, it is in line now. And actually you add a small perspective that I find really very, very interesting, that the way you use, you mention abductive reasoning here is related, but goes in a way farther than what I'm talking about. And but it's completely in line, okay? And yeah, the thing that the word abductive reasoning is pretty confusing, I think. And but it's exactly what I'd like to go into. Yes.
Yeah, maybe we should use a separate term for this. Abductive reasoning is explaining a set of facts with the most plausible theory. I guess what we are talking about here is more like abductive synthesis. Like given a set of affordances, what's the synthesized sort of detailed command that can fulfill an abstract goal? So yeah, I'm kind of using it very loosely, but I think it's a very related kind of thinking, basically. That's why I'm connecting the two.
Oh, formally, from my perspective, you're right. I mean, it's exactly the right word. What I wanted to say is that it's pretty intimidating word. And also there is the word abduction that is by most people used in a very different way. Okay, and so maybe it makes thinking about it a bit difficult. Okay, and so that's what I meant by perhaps using another word. But the way you use it for me is really spot on, and actually in the formal terminology, correct.
Maybe we need an informal term, like something related to Sherlock Holmes.
He's doing deductive reasoning, right? But well, I don't have a proposal now, but I'll try to think about it as well. But what Venkat explained, I think it's something to keep in mind. Okay, is that it looks like a big word, deductive reasoning, okay, but it can be a very simple mechanism when we implement it. Okay, I can show some examples in the future if you want. Okay, but the thing that these tiny mechanisms can have a big impact. Okay, and so. You know, when we discussed in the past, what does it mean to go forward? Okay, how do we translate that when we have wheels or legs? Okay, it's a kind of mechanism that can be very useful there. Okay, exactly what Venkat just said. Basically. Okay, so no offer for a better word right now, but I just wanted to stress that it's a difficult word, I believe, unusual word. Okay. But there is something there that that we could leverage, and that could be pretty unique compared to other builds of rovers out there.
I think I've been struggling a bit with the abstract nature of that word and trying to actually apply it to, for me to be able to wrap my brain around how it would actually apply to a rover. And I think that like taking the abstract concept of moving forward or moving to a specific location and then mapping that to the affordances of a particular rover is somehow more clear, if I'm grasping that correctly.
Oh no, that's a great way to put it actually, and it's one of my hope that in this group we kind of figure out where abduction reasoning fits in a concrete way. Okay, and the thing that the thing to keep in mind is that if we build a rover, if we are all building a rover, we will never talk about such kind of topics because we will just build the software to make the wheels or the legs work. That's it. Here we are talking about a rover platform, basically. Okay, not platform, framework, I would say. Okay, and so this is where such kind of issues come in, because if we have a framework, maybe we have, you know, a kind of software architecture where we have adapters. Okay, an adapter for legs and an adapter for wheels and so on. Okay, these are best practices when we write down the software, but on the way we are going to actually control the wheels, to actually control the legs. Okay, this is where it's a lot of work to make a framework that is adaptable to different hardware. Okay, and I guess that's one of the reasons why, if we take an advanced framework like ROS, for example, as far as I know, in a ROS, it's a framework. They provide a lot of facilities, but if we take something that is a bit unusual, okay, I think ROS works well with anything with wheels, basically. Okay, but if we have legs, I'm not so sure about that, but I think with legs there is more work to do. Okay, and the thing that concepts like abductive reasoning can maybe help us in making an actual framework that is adaptable more easily, if not automatically, to different hardware. Okay.
Cool. I got one more thing to show here. Do my best, Steve Jobs, and one more thing. I realized that since I've got all my telemetry data just on disk in a log file, I can export that to standard observability tools and create dashboards. And I can even have like all my logs collected here through this nice web interface. So at the top, I've got both my motors. This is the signal strength of the radio. And this is a completely jacked up graph that was trying to show what error code is being shown, but it doesn't work all that well. But let me make this thing go. and doesn't update immediately, but it's pretty close.
So what's the framework you have used for this?
So this is Grafana, and it's pulling data out of Loki, which is the Grafana stacks version of log querying capabilities.
So Grafana is something Go based, or
Grafana, I think, is almost purely a web interface.
okay.
It's like their whole philosophy is that this visualization and web interface is almost agnostic to where the data is coming from, and so you can connect it up to tons of different backends. The ones that the company works on them like themselves, they have a logging backend, and they have a metrics. It integrates well with like Prometheus, if you've heard of that, as for metrics. It does have a lot of Go in there with their whole kind of tool chain is Go, but their big thing is that like with the Grafana, you connect to whatever data sources you want, and they have the plugins for all those. I actually wasn't sure that I would be able to simply generate metrics based on log files. I thought maybe you'd have to like put them into like a metrics data store and figure all that stuff out, which I wasn't really looking too forward to. But it turns out you can just kind of, with at least at this scale, it was pretty easy to just like build it based on the logs. It just like parses the JSON and extracts the data out of it and puts it in a nice little visualization. And so that's another thing too, that a resource that would be easily shared amongst a bunch of rovers is this is running on a server that I have in my basement, and but it's actually just a Docker container that you can run anywhere. So
yes, this would be interesting to take.
Yeah, and I assume also because it's super easy to, or I don't know, super easy. It is possible to connect to almost any data store. Having whatever your rover's last sent image show up in this dashboard would be a pretty great interface, or being able to embed the stream that you had been working on. I'm sure that's possible. I have no idea how hard it is to do, because I struggle enough just to get the logging stuff to work. All right, so last bits of talk here. I wanted to talk a little bit about the challenges I had with working on that radio interface. I was really struggling to get it to work in any sort of like functional way until about 30 minutes before this call. I had the idea that or I was reminded that Mayor spent a lot of time adding mutexes around certain device access and solves a bunch of problems. And I was like, I wonder if I did the exact same thing and totally didn't even realize it. And I looked at the Python code, and sure enough, it was like multiple threads accessing the same device and causing all kinds of like wacky behavior. And as soon as primarily it looked like everything was super slow, but I think it was like some sort of like contention within the device itself. And so I added some mutexes, and it solved my problem. And now the radio seems to be working fine. So I don't know, maybe it's going to be just fine. There's also problems, as I alluded to,
Python,
that like,
yeah, working fine in Python.
it was working. It is now seems to be working fine in Python. So the fundamental performance problem was that I was having issues with, I would send a packet, and then you have to turn your radio into listen mode from transmit mode. And that's all done in user space in Python. And when I measured it, it seemed like it was taking about 900 milliseconds to send out a packet and then switch into listen mode. And I was like, they can barely do anything functional with something that slow. And that was 2 orders of magnitude slower than I was seeing in the Arduino, even though the Raspberry Pi is that much faster. Just the way the interfaces worked, it's like, oh, this is all taking so long. But it turns out adding some locking seems to have sorted out most of that problem. And now it's about 10 milliseconds to swap. So it's tolerable.
Is it due to the GIL of Python, or like multi-threading doesn't work well there?
You know, I sort of thought that I would be protected by that. Like I could get away without not having to worry about it because of the GIL.
Okay.
But I don't know I think that because it's actually two threads are interacting with a hardware device, that's
Okay.
allowing them to swap back and forth. And what happens in this particular program is because it doesn't have interrupts, it basically has to pull hardware super fast, and it's doing it in two threads sometimes because sometimes it's trying to send out a packet, it's pulling to see if the packet has gotten sent. Meanwhile, the listening thread is also pulling, trying to see if there's a new packet coming in, and they collide and lock everything up, I guess.
GIL is a global interpreter lock. It's like a problem in multi-threaded Python applications.
Yeah.
Thanks.
So the other issue was portability with my networking code. When I just had two Arduinos talking to each other, I could do all kinds of like lazy things with how I dealt with structures in C and not having to deal with padding and that kind of stuff. And then as soon as you've got an 8-bit Arduino talking to a 64-bit Raspberry Pi, suddenly that stuff doesn't work quite as well. And so I had to rethink some of my network protocol to be a little bit more strict, which I guess is for the best, but I didn't realize just how nice it was to be able to be lazy. And then I think maybe more importantly for our discussions here was like, when I started this project, I essentially scrapped the old ground station and completely tried to move over to this new thing and only worked on trying to get this ground station to work. And it took so long for that end-to-end connectivity to get back to where it was on a functional basis before. It was kind of demoralizing to have just like this broken system for that long. It was like, and the problems are all hard. There was no like, I can just pop in and work on this little thing for a little bit. It's like nothing works until I solve these really hard problems. And that's a dangerous spot to get into because I was getting really close to like, this networking stuff in C is really not fun anymore. And I'm just gonna have to throw it all out, which I would have felt bad about, but I mean, it's probably silly that I'm doing it anyways.
The Rover system like was broken. Did any of the hardware break, or was it just software?
It wasn't that the hardware itself broke. It was just that I had confused the software so much trying to get it to work in these like small bursts of attention that I had to add that like I couldn't easily like back it all out and get back to where I was. I mean, I could technically do it if I really tried, but it was just a little. There was a better solution would have been able to like replace one small component at a time and try to get that working, but that just didn't really work so well with the way that the architecture was before, if that makes any sense. And then the other minor point that I brought up before is that on the hardware side, on the Rover, it's actually less reusable now than it was before because I've got like my motor controller and hat like these and the Arduino Uno, they fit right together and they're all really well integrated together. And if I wanted to swap it out and use a different Arduino or something, it would actually, I just basically start over from scratch. And then, so we're at an hour. I had some extra stuff about talking at a higher level basis about systems engineering, but we don't necessarily have to go into all of that. It was just a little bit of research project that I had gone into. I will, those slides are shared in Discord. So if anyone wants to look through some of those, that's probably almost just as valuable. Yeah. Any other questions? Any other?
I'd be very happy to hear you did a digression into systems engineering, but it had to do with the Rover.
Yes.
And things that inspired you. So I think that would be very interesting to hear your experiences.
Yeah, I think the inspiring part of it was, or I think the most important takeaway was thinking about the Rover system at different levels of abstraction. And that seems to be fundamentally what systems engineering is about having engineers who are focused on how overall systems work. And it's really hard to decide where that system boundary is. And that's the really important part of systems engineering. So there's tons of other like formal project management, modeling language stuff that you can go into in systems engineering, but I don't really think that's very interesting for Yak Rovers. But from our perspective, I think making decisions, just like what we were talking about saying like, how are we going to define interfaces to allow rovers to collaborate, you suddenly have zoomed out your level of abstraction for where you're making design decisions. Suddenly you're no longer worried about just how your rover and your ground station work, or even just how your rover works. Like you got to keep like zooming out until you can see like a larger image. And even just collaborating between rovers is certainly not as high as you can go for things that might matter. Like you might go out another level and say like, what does this design say, or how does this design impact other people being able to join in on the project, or how does this design impact rover engineering globally? You can kind of get quite carried away with how far you want to zoom out and where you want to make your decisions. So I hadn't really thought about that in any sort of organized way before, but certainly some people, when they talk about systems engineering, have, which I thought was interesting.
So I'm translating what you're saying into an action, and it sounds like we should have somebody, maybe from outside the group, talk about system engineering perspectives in rover design.
I think it'd be
Especially-
really interesting to hear someone who has a lot of experience with real world systems engineering, how it's like they had that title on a business card, and what they would think would be relevant to the projects at the scale that we operate at. And I wonder if, I would kind of wonder what that perspective would bring.
I would just add in the twiggles that Eric mentioned, that each one of us, we have at least 5 different rover designs going on. So it's not system engineering of a rover, but rather for a diversity of rovers.
Yes. So one of these stories told by, I'm reading this book,
Yeah.
Art of Doing Science and Engineering. Richard Hamming, if you ever heard of him, he gave some lectures, and
Yeah.
one of the stories that he was telling was about working on the Nike missile defense system, I guess in the 60s. I don't know when that was, a long time ago. But they spent all this time working on how to get one missile to hit one aircraft as a defense, as part of the defense system. And then as soon as that works, the whole problem changes. Now suddenly you got to figure out how to coordinate a whole arsenal of these missiles. And then once you kind of figure that out, how that works, now you've got the whole system changes again. Now you've got to think about how do you like position these arsenals to protect individual cities. And so I thought that was interesting from 2 sides, was that like, oh, there's different levels of abstraction, but also those other levels of abstraction totally didn't matter until the lower ones had been figured out. And it feeds back on itself.
The discussion makes me think about something I thought recently, a few months ago. For some reason, a few months ago, I remember a movie that I watched when I was much younger. And what's the title of the movie? A Short Circuit. I don't know if you know about this. You know that movie, Short Circuit?
Oh yes, yeah. I just watched that recently, actually.
Yeah. Oh, really? Okay. So
yeah, I'll
for
watch
some
it
reason,
again. Watch it again. Yeah.
And so it turns out that for people who don't know, it's a kind of movie comedy where they have military robots. Okay, that one of them is struck by lightning, and it builds up some consciousness, basically. Okay, it's a more comedy kind of a movie. Okay, and so that movie is actually pretty famous, and that made me want, because of our project, made me want to know who was the designer of the robots. Okay, and I forgot his name. His name is Sid something, and he's a famous systems engineer. Okay, and the thing that he passed away. Okay, but there is another person involved in the movie, in the design of all those robots, and a few stories around that movie and the design of the robots. Pretty interesting, actually. Okay, and it turns out that this guy, his name is Eric Arlard. He lives in Los Angeles. Okay, and he's got his own company, and so I don't think he's too much into systems engineering. Huh? But the thing is that I wonder whether there are not people like that, maybe not now, but maybe later, that would be interested to talk about what it is to put together a robot for a given purpose. Okay, and so of course there is military. Of course there are companies like Boston Dynamics, but I'm not sure they are open to talk. And so that's something I had in my mind, that in the entertainment industry, on an old movie, so people who are now in their 60s and so on, but who did it by themselves, okay, may be pleased to share their experience. I don't know. And Eric Allard is apparently pretty active, okay? And so who knows? If what I'm saying now can trigger some ideas about people in systems engineering, I just know academics basically, so it doesn't really help much.
One other random aside, as I was kind of reading about this, like different people's opinions about systems engineering, was, and then when I saw I think the Twitter poll that Vikatesh put out about whether other engineering is like software engineering, and I think I answered slightly, and then I think I changed my mind the next week to be like, no, it's all the same. Because like in a system, like systems engineering specifically, you look at the lessons that people are learning, and then, oh, actually it's we do the same things in software engineering for larger projects, but it looks different because all of the subcomponents and all the sub expertise are all still software, but they are actually very like distinct components that have to relate together and hopefully abstract ways with defined interfaces, and a lot of the same things seem to crop up. They just have a slightly different flavor when you don't have to worry about mechanical systems and how they interact with electrical systems and how they interact with the social systems. And I think I'm going to start a systems engineering department at work.
Do we spend a little bit of time on the slides you've shared on systems engineering?
Oh yeah. Okay, so the previous one here, there is actually a fundamentals of systems engineering course in MIT OpenCourseWare. I've not listened to them all, of course, but I started to just kind of like poke around in some of it. It very much has the flavor of like, this is how to succeed inside of an engineering bureaucracy, and it sounds kind of painful. It is a graduate level course, and there are some people on it, like you hear like class discussions, and there are people who have like worked in other projects and can give the experience of like, oh, this is what happened at SpaceX when I was an intern there, and that kind of stuff. So that's kind of interesting. I will probably actually listen to more of it, even though it's not necessarily directly relevant. And the funny part I thought was that Richard Hamming spends a lot of time talking about how it's really impossible to teach systems engineering. So you should never have a coursework for how to do systems engineering, which I think makes a certain amount of sense, because like the hard parts from his perspective are not the things that are being taught in that course. I don't think, like, how to not screw it up is not necessarily well covered. He had some, and he also just mixed in some like random rules here, but are probably less interesting. What else was I gonna say? yeah, that whole story about like systems engineering job is never really done, because as soon as you have some piece of a solution that fundamentally changes the nature of the problem, resonated quite a bit, I think, for me at least. And then I don't know if you guys have watched this series of videos with Elon Musk wandering around the Starship factory, but I found it to just be incredibly enlightening, just from, well, now from a systems engineering perspective, but especially when you kind of compare it to, like, I realize now that he's talking a lot about what you do when you have a whole lot of engineers that went to the systems engineering course at MIT, and then they worked on a NASA project, and now they're working at SpaceX, and you try to get them to unlearn key aspects of it, because the way that they're trying to build a rocket is kind of a very different way, and it's a different approach. And he even said, trying to like really want us to make everybody the chief engineer, so that they all keep the entire project in mind at all times, as being just like a core principle. I'm sure that's not fully true, but
SpaceX, yeah, operates kind of differently from the others. Like for others, like a crash would be a PR disaster.
Exactly. Yeah. Like he spends so much time talking about how like the FAA is just gonna freak out. Like the idea that you are okay blowing up a rocket is absurd to them. But it seems very valuable. Like the lessons, the things that end up causing the rocket to blow up are not the ones that they actually had on their risk list. Like that's wild, right? All these things they were concerned about, nope, but not the real problems. The only way to find them is to actually fly the rocket. So anyways, if you haven't watched these series of videos, they're pretty interesting. And then this other one, this is a pure software thing, but this just keeps coming back to me. I talk about this video quite frequently. But the idea here is, I mean, very, very like abstract terms, trying to tease out the differences between something being designed to be simple and something being designed to be easy, and just how common it is for us to reach for those tools that are like nearest to be like, oh, this is easy, everybody knows how to use Docker. But it's actually like easy is not the same as simple. Don't mistake that with it's simple, just use Docker. And I'm picking on Docker for no particular reason, but whatever technology seems nearby, it's like, it's not necessarily the same thing as being simple. And it did get me thinking a little bit about this, like the transition from having the ground station be based on the Arduino and having it be the Raspberry Pi is like, there is a loss of simplicity there that I'm going to miss, because the components were a lot simpler in how they interacted. And now there's a much more sophistication in how these components interact, but there's a whole lot more functionality. And so there's just, I don't know, the idea about being intentional about those changes and knowing what you're getting into. Adding a Unix system does not make it simple, but it certainly was easier to get a lot more functionality. So, but that's also a great lecture if you haven't seen it.
ROS is like the simple, easy thing, right? I'm not sure. Like it's something everyone reaches out, from what I see, for robots, at least by default or something.
Yeah, and I've been wondering how much of that is it's easy because people are familiar with it and there is lots of other software, or how much of it is like, I don't know how to make a decision, so I'm going to use the thing that everyone else has been using. I still don't know. I'm still skeptical about that. Trying to wrap my brain around that. That was what my last talk was about, essentially. So I'm always open to hearing from ROS experts, and please convince me. And okay, so, and then just some last questions here that had kind of come up. I kind of touched on this already, of just like design tensions between making decisions that work well for one rover versus those that work for a collection of rovers, and what are those tensions? and then acknowledgement that my takeaways from all these comes coming from like a software engineering background. And so I'm always interested to hear from anyone who has different backgrounds, what their, if they think those takeaways are fair or not, or what else I'm missing. Anyone have thoughts on those? We have at least one mechanical engineer.
I don't have any tension. In other words, I go in the direction of fun. It happens to be that sometimes it's also good for the group.
Yeah, I think we'll discover the tensions when more of us get to the starting line. I think some of you are already doing things. Some of us are trying to get to the starting line. But yeah, I think we'll discover a lot more of this stuff next year when we get a little further along. But I think what we're doing so far has been pretty healthy. Like where there is a natural collaboration overlap, like Victor and Mara are both using the Docker container VPN architecture thing. It works out naturally, and that's, I think, a nice kind of like synergy overlap. I think what might be, let me put it this way, since this is a fun volunteer part-time kind of project, if the collaboration is not fun, the only reason to do it is if somebody is paying you to do it. So in a actual engineering company, when there's a job and everybody says you two groups have to do some synergy, then they pay you to overcome the pain. And that's my experience here. So it's like, if in a company you would only do it because you're being paid, then that's a reason to not do it in this project. Because I think one of the sort of social things we're discovering here is how far can you get with just informal volunteer collaboration and only sort of, I don't know, trying to collaborate when it's actually fun versus not doing it if it's not. And I think that should result in some interesting design decisions and stuff. I mean, it's kind of like, open source logic. Open source kind of works like that in software. And in a way, nobody has really tried open source in hardware properly. So this will be kind of interesting to see that work out. Like a lot of what you guys are talking about, there's a very good reason I won't be doing any of it because I'm completely incompetent in that. Like, I don't know as much software engineering or running like cloud infrastructure on Raspberry Pi and all that stuff. You guys are doing like some serious black magic here, which I know for sure I won't be able to do anytime in the next couple of years. So there's like things like that. So in a way, that's a robustness filter. Like if you have people with very varied backgrounds and abilities, then you naturally hit a least common denominator, and the only things people use will be things that they can use.
There is also a filter kind of, this is like a lot of time and money investment for your hobby projects. So maybe, yeah.
One of the things I'm surprised by is actually the money is not turning out to be that hard. Like all this stuff that we've been building, it's relatively cheap, and we're all working mostly in the Western world, and we can kind of afford this. And Sai is going to go to Germany now, and you'll have all the resources of a university lab. So it's funny that the constraint is turning out to be time and skill more than money. Like I'm willing to throw 5 times as much money at my project than I am now. Like right now, I think I've spent like, it's still under $1,000. The only thing is I'm not sure that would help. Like if I spend $5,000 instead of $1,000, I don't think it would speed it up any. I'm now at the bottleneck where the bottleneck is my skill and time. Like throwing more money at it won't actually help at this point.
My pile of unused Arduino variations agrees with you.
I just want to say that we're going to drag you screaming and kicking into the 21st century.
We will see.
Yeah.
My limit is MATLAB and Hello World at Python. So I would be very shocked if I can do any of the things that Rhett is pulling off here, like dashboards and radio communications through Unix sockets, all that shit. I would be very impressed if I get to like 0.1% of any of that.
I'll be honest, I'm still astonished at how hard it is to build a dashboard for something. I'm like, where the incantations that you have to Google for to get some of the stuff to show up is bizarre. It's
but
state of the
it's
art.
impressive if you take the union of all we've done and pretend that one person did it all. That person looks like a genius. It's like so many different skills are coming together that no one person can pull together. And honestly, this is kind of interesting because even in like corporate labs and university labs, for some reason, the filtering of people works differently and you end up with a lot more homogeneity. Like I was at an aerospace and mechanical engineering lab, and the overlap between all the grad and PhD students was like on the order of 60 to 80%. Like we had roughly the same redundant set of skills, whereas this group is like far more diverse technically than any technical group I've been part of. So that's interesting in itself, I think.
Yeah, the other difference I've seen is in robotics. A lot of people come from the software background, and that also from higher levels of software. So whenever I was used to be in the like robotics teams, like I was the only one generally working on the lower levels of software, and then like hardly meeting any mechanical engineers.
Yeah. Well, since I'm the only mechanical engineer here, I'm totally outnumbered by all you software guys. So next year, my priority is going to be beef up my side of the team by recruiting some more mechanical people. All right. Anything else? I guess we can stop the recording of this session. And for next week, technically, we're supposed to have a talk